Namaskar, good morning, good day. This is Suraj Singh speaking for Bharat, India, and this is August 7th, 2020. One more day of life coming in, and we are all in same boat, same problem, all over the world. This problem cannot be ignored. Problem of COVID, problem of life cannot be ignored anyway. However, we have to tolerate this. Chartered engineer, professional engineers in Bharat, India, and this talk as usual regarding regarding issues, that is what do you say, COVID, and then or something like this, and then you can say management, etc., and you can say predict, etc., predict, and then you can say all that as you think is right. As usual, life of reality, paper writing, old style, in which I was born, in which I learned. I spent my major portion of learning. That's very important one. We said that life is like that. One way for calculating. I actually called my mobile, cycling a park. My mobile, which I will show you. I missed that. Well, I missed out what to do. It happens. This is life, and you forget so many things. And now, as usual, I try to show you my yesterday's video was lost in Facebook. I don't know how it was lost. I use new page of Facebook, but I'm not happy with that because I face so many problems and my page is lost. It's just I used YouTube at that time, so YouTube showed it. Facebook did not show it. So at least that is on YouTube, and unfortunately I saved it on YouTube, and YouTube is giving that, but Facebook has lost it, and they have no response. I wrote to them, they did not give any response on that, how it was lost. So I then switched to classical style because I think we are not ready with new style yet. Maybe some problems. No issue, nothing, what to do. It's life, sometimes you have to lose, sometimes you have to lose, it's up to you. Sometimes time is normal, sometimes not as normal, and there's light problem also, electrical problem. So gentlemen, what I say, you have to, sometimes we are to face everything. That is not expected to be faced, but we face. We have to face that. Due to whatsoever reason. Technology has a limit, but if you want to, technology has a limit, you cannot simply say, see this will happen, no. But I said, oh no, that's not what I said. This is bloody fool. Messages don't stop coming in. Nonsense. These messages, yeah. I'm fed up with these messages. Just doing nothing, only sending messages. For what? I don't know what they want to stop. It's disturbing all the time. These people don't understand. Somebody is working, disturbing, nothing, just sending messages, and I really feel angry sometimes with these people. These people don't know. Well, Bharat, India has crossed 20 lakhs or 2 billion COVID cases of infections. This is bad news, you can say, unpleasing news to everybody, every member of Bharat, India. Today it is 20 lakhs or 2.0 or 0.2 crores, you can say, or 2 million. This means it is start of a difficult journey by everybody of Bharat. 20 lakhs or 2 million, I think it's soon reaching to cross Brazil as well as USA. USA is around 5 million, I believe. 5 million and around maybe 1.8 lakhs people lost their lives. 180,000 have lost their lives. Sad really. And around 50,000 lost their lives in UK, also sad. World is, people are leaving, they are leaving from world, and it's really, very sad situation. Well, it's not in control of anybody. Nobody can say anything onto this. I had nothing to add to this news because I could not view news since afternoon yesterday because of electrical problem, and also still my desktop is not working. I am speaking from laptop. Life has changed, we know. We have to live with new style. There is no other way out. Nobody can do anything in this, because when something is unknown, what can we do of invisible? Everything is hidden, concealed, and can say darkness exists, but we know once darkness is crossed, light comes in, or when light comes in, illumination comes in, hope of ray comes in, darkness goes. But we should respect darkness also. Remember, if we don't respect darkness, we cannot enjoy light. Enjoy means not pleasing, but use it. Find a way out of that. But if we remember, darkness is full of secrets always. We should understand this point. Darkness does not mean black. It means something is secret there, which secrecy brings in light. Or you can say, light hides that secrecy and darkness hides that light. Darkness can also hide and say, show you your real brain, your real imagination, because in darkness you cannot keep your physical eyes open. In that case, physical eyes are closed, and your mental eyes are secret eyes open. This is what I think. Maybe I am wrong. I cannot guarantee that. But COVID-19, I cannot say that this is light. Of course, this is very big power in a century, which has defeated humanity. And humanity is bubbling. Humanity is not in patience. Humanity is nervous. All learned people are nervous. By trial and error, by hook and crook, solutions never come. Until we understand root cause of some problem, we cannot find any solution. And this is what is happening now. Root cause is not known till now, and it's more than 9 months. This means some great power is working for this. I always suggest public, my country public and all public not to be in panic, and not to also be in a mood that you have to remain in same style of life which you have been enjoying or you have been availing prior to COVID-19. When God has forced you to change your style, you have to change your style. Means it has not changed drastically, only that it has required you now to at least take protection from this, which is only way to, just like you use protection in dusty weather, just like you take protection, you can say in rain, you use umbrella or use something else. This type of protection is only, I think, necessary in this case. We should not be discouraged, because what God does, it is always for good. Particularly for those who have not experienced a struggle in life, current youth, it's for them that they should be they should at least think of everything, and I hope that they would do it. Life shall come and life shall go, people shall come and people shall, this keeps on and on and on. But what happens is that we should be serious enough to understand everything. Now I jump onto management rather than staying on point, because there is no use to talk same thing again and again. Engineering management, and we call it project engineering, or we can call it anything. It is a combination of these two specifications as compared. Yesterday I talked of what I talked of, remember? I talked of microstructural analysis and magnetic characterization of native and magnetically modified montmorillonite and vermiculite. This is portion of soil. You know, montmorillonite is mineral of clay soil, and montmorillonite and vermiculite are groups in clay. These are minerals of clay, and clay is full of minerals. If there are no minerals, there is no clay. These are very, very bad for engineering foundations, and these are good for some medical issues. This is what we could understand from this microstructural analysis and magnetic characterization of native and magnetically modified montmorillonite and vermiculite. So there are two ways. One is we have studied microstructure analysis, and which is regarding its composition geometrically, how it is in structures, in its microstructures. That is, double triangular, equilateral triangle, one opposite other, an extension of those in which its electrons and its atomic structure occupies or consolidates. That is microstructure, and that has octahedral and tetrahedral connections and one. Because the layers, we call them two layers, and one layer, 2:1, to tetrahedron 1, can say 2. But one octahedron is middle layer, can sandwich between two tetrahedron layers, and which is beauty of this, that there are so many chemicals in that, which chemicals have cations in tetrahedron, in octahedral layer, and other one O and H in outer layers or upper layer in lower layer, and its extension that we discussed at length, and how it works, how it modifies, how it changes, its modifications and its native properties. As we said, we discussed microstructural analysis. This structural analysis is simply modeled, and it's beautifully modeled. It's completely modeled in indicative form, and then magnetic characterization of that, application of magnet modification on these two, where there was no major results as far as monoclonite is concerned. And vermiculite, means swelling is indicated by monoclonite. For it swells because of this connection of water. Adhesion is swells in, but otherwise there is pillars as set in this, because even of magnetization, that pillars keep these layers apart, and there is no modification in that. Because of that, chemical sieve analysis, sieve is formed in that, and it does not allow it to come. So that's no modification by magnet force also does not change it considerably. Only then we can say, external water, you can say that water swells monoclonite, and we all studied about this, how vermiculite and how monoclonite, and all iron oxide was a player there. Iron oxide was a player in this, and how that works is also we have understood. How is this iron oxide? So what we actually studied in this, we first studied on page 2 of 25. That is, this is structure, indicative structure, and that we call it phyllosilicates. So it's phyllosilicates, basic structural unit of phyllosilicates is called, which is having double tiles. Figure 1 in this page, and this is integral part forms sheets of octahedron X0OH. And also then we studied about, and also in this we studied octahedral cations. Octahedral cations, that X mostly Al, Fe and Mg we studied. This is in octahedral sheets, and occupation of structural positions in octahedral sheets, which generates tri-octahedral sheet silicates. This is occupation of structural positions in octahedral sheet, which generates tri-octahedral sheet silicates, where each O and OH is surrounded. O and OH is surrounded by 3 divalent cations like Fe, etc. That. And then those 2 or more extensions of these sketches which we discussed about where chemicals stay, and all those we discussed about. If we go further, that new materials can be designed for this. It said that new materials are designed to improve efficiency, absorption efficiency, and decrease in price of purification, because this is also used in some other than foundations. You use this minerals elsewhere for purification technology, and that enhances functionality of material. In order to improve absorption properties of clay minerals, different acid activation and other chemical procedure modification were developed. Most of papers are devoted to improvements of clay minerals from viewpoint of their applications. Now, clay minerals modified by metal oxides in their interlayer species are known as pillard, as I said. Modification of clay minerals by metal oxides is known as pillard clays, and oxide particles act as pillars and keep silicate layers apart in form 2-dimensional molecular sieves. And compared to original clay minerals, they have a high fraction of surface area. high fraction of surface area. So we have say that in this paper, in this case, we have studied devoted to analysis of complex structural and magnetic properties of magnetically modified montmorillonite, that's MMP, and also vermiculite, that's MWORT, MBER, using iron oxide particles and original unmodified clay minerals, which is original is MT and VAR. Structural properties, morphology, and chemical composition are determined by X-ray fluorescence spectroscopy. Methods we discussed for modification one was XRFS, that's X-ray fluorescence spectroscopy, and that is then an SEM, which is scanning electron microscopy, and then it is TEM, transmission electron microscopy, and X-ray diffraction, XRD, macro and micro magnetic characterization of samples are achieved by magnetic and busbars measurements at known room and elevated temperatures, completed by low temperature measurements in Mazabur's measurements at room temperature and elevated temperature, completed by low temperature measurements. Then we had to see experiments whose details we could not find in this paper, but then there was transmission electron. First method is, as we say, XRFS, fluorescence. Second method is SEM, which is transition. It's not given here. Also, the other one is transitional electron microscopy, then X-ray powder diffraction and Mazobars spectrometry, and some technical formula and results. We studied chemical compositions of morphology. We studied that one, and then we came down further to see this test some indicatively, and we have to see how vermiculite changes from one to other one, which is also very important. That says MWORT says that some microns iron oxide nanoparticles occur at surface and intergrain of MBR and MMT samples, and that their size is unsurprisingly larger at MM of samples. Through procedure was same for both clay minerals. That corresponds with the difference on XRD patient of modified samples. Then we studied about more on these curves of magnetic application and in different temperatures for MWORT, and that was 2 theta equal to 21.79, which raises to 29.07 degrees to 36.48 degrees to 44.27 degrees and 52, which is nearly same positions at present. It can be only speculated that magnetic modification did not affect the structure of sample. From a structural viewpoint, more detailed studies to be done. So we move further, and then we saw Mazobers spectrometry, which is a little different. Then this can use since the iron oxide said Mazobers spectra of original MTVR and magnetically modified MMP and MBR, montmorillonite and vermiculite samples recorded room and low 7K temperature are depicted, while X-ray diffraction yields information on major minerals in clay. Mazobars spectroscopy looks selectively at iron-containing compounds that are often difficult to detect by X-ray diffraction due to their low concentration, small particle size, or poor crystallinity. Nevertheless, also a unique interpretation of Mazobars spectra can be sometimes difficult or impossible, either because a spectrum cannot be decomposed in a unique shape into individual components, or because different iron-based components have very similar Mazobar pattern. Sometimes it's helpful to supplement measurements at ambient temperature by measurements at liquid nitrogen or helium temperature. So Mazobar spectrometry is different. different in a way that it involves iron oxide, or you can say major minerals and clays, while diffraction X-ray diffraction yields information on major minerals in clay. Mass spectroscopy looks selectively at iron-containing compounds that are often difficult to detect in X-ray diffraction. Diffraction due to their low concentration, small particle size, or poor crystallization. Then we had to went through the details for this. Now we are here. If you just move on to, we discuss about magnetic field and magnetization, means all application of magnet which are in details. Few details we are not very clear, but we just get some information about this. At room temperature, at low temperature, we get, and then we can see these magnetic interactions were referred to many analysis by many scientists, and then this we discussed about various low temperature magnetic properties of magnetic modified and worked MRI samples. And as then this conclusion, then we went to conclusion, which I can repeat is better, which is very important for, so that I can start another file. And in conclusion, we studied that Mount Morillonite from smectite group, and smectite is one of group of clay. Mount Morillonite from smectite group, and vermiculite from vermiculite group. So one group is smectite and other group is vermiculite. Group were magnetically modified by mixing original clay minerals. Original clay minerals magnetically were modified by mixing original clay minerals with iron oxide particles prepared iron oxide particles prepared using a microwave irradiation procedure. Complex, you can say with iron oxide particles, it says minerals, modified by mixing original clay minerals with iron oxide particles prepared using a microwave irradiation procedures. In this case, we use iron oxide to mix with original clay minerals, and we just see how they react. Complex structural and magnetic studies of original and magnetically modified powders were performed using scanning and transmission electron microscopy, using STE, scanning and transmission electron microscopy. Scanning, that structure, and transmission electron microscopy, and also X-ray fluorescence, which is XR, fluorescence spectroscopy, which is XRFS, and also X-ray diffraction. Then these three, and then separately Masvow's spectrometry and magnetic method at room temperature. Most of results supported also by low temperature measurements. Both clay minerals of 2:1 layer type and SEM, which this is scanning, SEM scanning and scan electrons microscopy. SEM observations yield similar morphology and large area as local dot chemical homogeneity of all studies samples. Nevertheless, TEM micrograph clearly show larger particles. Agglomerates micrographs clearly show larger particles agglomerates at vermiculite sample, means vermiculite gives agglomerates at vermiculite sample, contrary to Mount Morillonites consisting of very small separated nanoparticles. Original clay minerals behave in a way corresponding to their composition. Vermiculite with higher content of iron-based compounds yields slightly softer magnetic properties and presence of magnetic component at low temperature, while montmorillonite is paramagnetic and or super paramagnetic at both room and low temperatures. Magnetic modification changes magnetic properties of both samples in different ways. Particle agglomerates in vermiculite cause magnetic hardening and prevailing dipolar interaction or dipolar coupling, which refers to direct magnetostatic interaction between two magnetic dipoles moments. Contrary to magnetically modified montmorillonite, exhibits supermagnetic behavior at RT. Contrary magnetic modified montmorillonite exhibits super paramagnetic behavior at room temperature with nearly zero coercive field and remanent magnetization. It means that temperature fluctuations of nanoparticles easily overcome barrier consisting of their anisotropic and isotropic energy, marked increase of Hc at 2000. 2K confirms that during cooling, magnetic nanoparticles attract properties typical of magnetically ordered materials and pass into blocking. PV corresponds to 158. So this way we studied, and I will close this file now because this file, now I'll open this one here. I close this file and that's down there. Now I'll go to other file which is in waiting now, which is very important one from this point of view, and this is now montmorillonite differential thermal curve, general variability in the hydroxylation region. This is an article. This is an article, and this was written by engineer or scientist R.C. McKenzie, and this title is montmorillonite differential thermal curve, general variability in the hydroxylation region, by Robert C. McKenzie and Institute of Soil Research, Craigbridge, Aberdeen. So let us say this. Before going on to this further, let us have some talk on. I have already put these few files, all these three soil related files which I just discussed, analysis by microanalysis, and previous one generality of soil, and this one that is curves. These files URLs are available. I have put these files in videos. I told it means not explanatory, just indicative comments on video, but you can see those files as projected there. You may know yourself what those files are. It's I put using screen share command. on Facebook. There was no other way to bring to you, either I use projector, but I think it's massive because you must have, related resource information, because I'm using these files as resource for explaining what is about soil. There will be more files. I'll jump on the investigation of soil investigation after this mountain light issue. And before that, we have discussed many such, like stone columns, like stabilization of soil, classes of soil, and how to combine various soils, various materials of soils into one for purpose of backfill, which is also very much important design part of soil, because soil I consider is most important part in engineering, civil engineering, or you can say building engineering or foundation engineering. I can say it's very important part of foundation engineering, soil, and also it's very important part in fill. Wherever fill is carried out, fill is effective. Wherever there's fill means different kinds of fills, engineer fills or general fills. Various classes of fills are there. Fills for granular fills for purpose to be used below foundations, and fill for purpose of general, I mean to say, everywhere there is no foundation, but fill is required for miscellaneous purposes, and many meters of fills have been reported, have been observed in just so many meters. The fill, like that, fill is very important purpose. Fill or excavation, both. As we are talking of fill, we have to excavate, because both are opposite to each other. If you don't excavate, we cannot do anything, and if you don't fill, we also cannot fill. If you don't fill, you cannot do anything. You cannot do groundwork, you cannot do upper works. So as far as soil is concerned, I am very concerned, I am very serious for soil, not because I am an engineer, but because if soil doesn't behave for designs, for expected, we have expectation from soil, just like we have expectation from every other material. I want to emphasize that soil should not be considered something else, but this should be considered most important material that is used in engineering, and this is material we excavate out, and also this is material on which we rest our foundations, and also this is material which we backfill around foundations, or we use cut and fill in road works, or whatever you can say, wherever you can say, no structure in world can stay without fill or without soil. And if there is no soil, if there is no soil, then I can say that we cannot make anything. We cannot make anything without soil, and it's not now. It's since this universe was built. I'm always interested in saying that, and to particularly those engineers and civil engineers, I always like to bring to the attention that you consider that you are engineer for universe. Not for universal working, but engineer for universal structure. Universe is also a structure for everybody. We should not just limit ourselves to what we are taught, what we already see we can do. We should not limit to ourselves, but we should expand our thinking, our contemplation means how this structure of universe or solar system could be produced by that engineer who is engineer, doctor, and every any title of this universe, and we call that power superpower, or we call that power whole energy, or we call that power God, or whatever you may call that power. There's no title I give to that, because most powerful person doesn't need any title. Title is needed for persons like me, like you, because we are identified by titles. But that power that's unknown, how can you give title to that? This means titles are only for those people who are known, and that's why title is given, because we know something, we know someone is this or that, someone can perform. So title in fact limits you and me. Title limits our identity. We are not unlimited in that case, but if you consider that power which is for you, for me, for everybody, that power is not limited, that power is secret, that power is unknown. Just like that power is secret, we know that secrecy does not mean, cowardice, or secrecy doesn't mean that, it's horror. To be very frank, secrecy is science. Once it comes out, it becomes science. Secrecy is something that we so far could not know it, or could not understand it. That is secrecy. So I say secrecy is good for something that you are hungry to know what that is. It's something like, sometimes by chance you are successful somewhere, by chance, without even you thought of that. Luck comes to you, fortunes comes to you. So until these fortunes come to you, you think these are secrets for you. Just like we say, death, after death what happens, it's secret for us. Yes, that's also secret. But what about this life? Do you know about this body is in totality? This body is also secret. Yes, medical science knows body functions. Medical science knows how this body operates. But medical science does not know even today who operates this body. If you ask some doctor, he will tell you systems, specialty and specialty. But no doctor can even say today how this body is operated, and how does this body stop its functioning, and when this comes to this world, how this comes, what happens in that chamber. All these are secrecies. So we should say we have also secrecies. Yes, we know from engineering viewpoint, we say we are engineering, we are engineers, we do engineering, that's true, we do engineering. But do we see engineering? Do we, just like we cannot see electrical current, we see electrical applications, we use them. We don't know how we are not seen, just like we are not seen how human body functions. Physically we are not seen, yet we know it is functioning. Similarly, we don't know how nature functions, but nature is functioning. Same way, we don't know how does a structure function, but a structure knows. We know theories of structures, and we know how to design that to whatever knowledge we have, and we do that all. But is that final? No, that's not final. We apply mechanics in our calculation, we apply strength of materials in our calculation, we apply theory of structure in our calculation, and we apply on top of that common sense in our applications. In parts we learn, not in full. We learn from parts to whole, while actually it should be from whole to part. Whole to part learning only very few people do, but parts to all, assembly engineers we can say, we assemble our calculations to other higher calculations. We don't bring out analysis from existing one or existing in our minds. Well, it's not debate of this here. There's no such debate here. It's only your contemplation and my contemplation. And when say contemplation means template itself with some design. So whatever we learn, whatever knowledge we have gathered about systems, about nature, whatever we have learned from existing knowledge, that's whatever we have collected, whatever we have understood, we call it science or a system. And which new system or whatever system we can understand make, that becomes a role for other one. That becomes a standard one. So this is standard is. So that may be standard or may not be standard. We consider that this is our standard of working. This is engineering management. So you have to do your work your way, and you have to design your way. You have to design your system. You have to design mechanism, and then you have to apply and see if this is valid to what you thought, or this is not valid. This works or doesn't work. The safe or not safe. All this we go through research or innovations, and we try that and do that. We cannot take anything arbitrarily until we have no other source just to apply that. Then you may say, okay, for time being we use this, but that's not a system. We don't consider that as a system. So before going to soil, I just wanted to explain to you why reason, and particularly those who are engineers and engineers in field of engineering, civil engineering we call it, in which there is no limit. You can say civil engineer has no limit, because civil engineer deals with structures and architectures and electricals and mechanical elementary works and coordinations, and you find anything wherever you will find civil engineer everywhere. Civil engineer, when I say, it includes all other engineers, coordination part of engineers. Electrical engineer, big one. Mechanical engineers are also big one. Big in a sense that without their input, we cannot produce a structure that serves in, that gives you complete service or modern service. So civil engineer is not exclusively independent, but depends on other engineers as well. And civil engineer means, when we say civil, this means we do on everything that is used by civil or which is not criminal. In fact, we are civil engineers, we say that we are civilized engineers, we say that. Well, again I say title got nothing with this, so title is not very important. Important is your function, your scope of work, your responsibility. You can say, how can you define yourself? You have to define, and how you define engineering, you define it. In engineering, civil engineering or project engineering or whatever is engineering, there are a lot of subjects. Not only subjects in university, subjects you have to learn and you have to use in your post-university life. Then you go to field, you work how you are, know that. If we don't understand that point, then we can say, no, we are not engineers. There is a difference between professionals, each professional. Engineer is such a profession which makes its own x-rays, which makes its own planning, its own. You will say, what he's talking of, always that. It makes it own. Yes, you are right, you make yourself, and I'm not telling lies to you. You make drawings, you will something in your mind, then you research on that and you want to. So I have decided I use this building in different form. I have revised this one. That's very important to understand here, that engineering is not a confined field. Engineering is not a work that keeps you in confinement. Yes, in some way you can say, but that's not universal. You cannot confine yourself in engineering, and engineering means civil, electrical, mechanical, I should say. Others are, I call them separately. Security engineering, or electronics engineering, or whatever else is there, exists there. I have different opinion about that. Because I am civil, it doesn't mean that I should see for civil only. I know in civil, if I study civil only, and if I don't care for others, I can never do my assignment. I can never complete job. That point I understand very well. Being a civil engineer, yes, civil engineering field, I passed civil engineering. This does not mean that I am exclusive civil engineer. Yes, civil engineering is my profession, it's my academics, it is my title, and of course I write civil engineer when I write, but this doesn't mean that I cannot do something else. I cannot do something else means once you are basic engineer or any whatever profession, you can learn very fast electrical as well as mechanical, particularly in our fields. I'm not talking here electronics or IT or agriculture, no. That's not field of civil engineering. Some part of mechanical, some part of electrical, and 80-90% part of architecture, civil engineer knows. Knows in a sense we can deal with, we can handle, we can understand. There's no rocket science in that. It's your mental work which is required to be done. And of course we have disciplinary connections in electromechanical, where we have qualified colleagues with us to support us, to help us in those structural makings. Whatever structure we have, everywhere there is services input, electrical service, mechanical service, and all other services, plumbing services, many more, elevator services, escalator services, and kitchen units, and many more. Though this makes us that we are not in isolation. We start in isolation, but then move forward, move project on and on and on. And project moves on some track to reach some destination. And when delivery is made, means before that delivery, commissioning is done, satisfaction is reached, and wherever there is work regarding whatever, we have to do that. That is very vast job, and in big times of project, you will find civil works already gone, finished. You have to prepare for some more, something else. That's what engineering is about. That's why my attempt is to disseminate you guys that don't keep yourself in isolation. Just by stating that I am in designs, I will do designs only. I am a structural engineer, I am a consultant because I am in designs. Keep this incomplete thought out of your mind. You are welcome, you are a reputed person, and you are a designer, but designer is not about engineering, remember. No structural engineer is about engineering. You are a part of engineering, you are a part of civil engineering. Civil engineering is unlimited sphere, unlimited field. It cannot be confined to say general engineer, no. Civil engineer means you have to be public engineer. Actually, civil engineer is known as public engineer because civil engineering deals with all issues with public. That's why civil engineering, I always find it different. We can define structural engineer separately, we can have something, but that definition got no relevance because no one can be exclusively structural engineer or no one can be exclusively other subjects engineers. You have to use your knowledge which you learned and which you learn now. Use that knowledge to reflect on your CVs and all to your, you can say, whatever. My dear, my explanation toward engineering is like this. See, if you see everything in engineering now, day by day, all syllabuses change. When I was studying, syllabuses were different, not exactly like today, but those were all relevant. I say in my according to my experience, no subject was irrelevant. At that time, you might think, well, cause this is not relevant, but now I feel that nothing is irrelevant, nothing. See, I studied social in our junior education, which we call diploma education. I also learned labor relations civics. In that, labor relations and civics and civics part, and was taught by some non-engineer, while other parts, you know, like duties and accounts, overseas duties and accounts, and also human relations. Human relations relate to what? Human you can say resources. All these were taught, and also as compulsory subjects were taught other than civil, electrical, and mechanical in various forms, like mechanical, not directly mechanical, you can say. I had to pass applied thermodynamics, for example, applied thermodynamics, which is a part of mechanical engineering, and then we have to type elementary designs, electrical engineering. Same way, you pass, fluid mechanics and social sciences. Social sciences, which means macroeconomics, microeconomics, and national economics. That's fact. At that time, you should think this is all useful waste of time. No, I didn't find that. No. There's no waste time on this, but I think you can better, you work better if you know such. You may have to go through many electrical documents from manufacturer. You have also go through contract issues, and you have to go through electrical designs. And if we consider time, no, this is not my field, this is not that, I cannot do this, I can't touch it. In that case, you stop yourself calling engineer, because it's job of engineer to keep yourself safe. Keep yourself safe in all ways, right? Well, gentlemen, engineering has defined many times. What is my conception of engineering? Engineering, I can say, as you grow in engineering, it goes further and further. Therefore, I can only suggest that be general engineer. Yes, you can qualify higher degrees, but that qualification does not mean that you have learned higher. Higher education, engineering, or MTech, or PhD engineering and MTech. Whole life you want to do a job site-oriented. That's not your fault. Site-oriented has I take some water before going further, because I have to talk of soil now, which is a good subject. I just had a gap in between just to explain why I'm doing this. And I'll be happy, very happy, if you people raise questions on this issue. I know there may be complaints from various engineers and public members that I am making very long videos. You are right. Your complaint is genuine. Your complaint has got some weight. I agree with that. And I also understand that they consider videos on Facebook, extra. If you have time, view that or leave them. You have every right to say that. You think, I have time? No. I have time because I am not doing job. It doesn't mean that I have time. What I am doing is, I don't want to die. I am leaving nothing for survivors, whole survives in public. I consider whole world as my family, not Bharat India alone. Because we come from same God, to we have to go back again. That God is honor of everyone from all over the world and to skies and other planets that I worked in overseas countries, particularly Middle East, Gulf. My contribution to those countries physically on sites and in offices is tremendous. I am satisfied with that I could learn and I could do something for that society. Those societies, you may call them overseas societies, you may call them foreigners, you may call anything. But keep in mind that whole world is one. There is no foreigner here. Whatever we say, that's relative foreigner. Because when we stay on this earth, all are in same land. Yes, you have divided countries yourself. I am not going to talk about that. That is manual, that is human, that is fictional, we can say. Fictional. That's not real. Really speaking, that you may divide any country, you may create more countries, you may call yourself, I am separate, I am other, I am space earth. You can call. It doesn't make a difference to skies, it doesn't make a difference to sun or to stars or to airflow. It doesn't make any difference. Virus COVID-19 speaks in high volume, high voice what I am saying. You may consider that I am talking on behalf of COVID-19. No problem to me, because COVID cannot talk to you, I can talk to you. Just like COVID-19 is proving that all are same in all countries. What proof you want that there is no country? We have grabbed lands ourselves with our powers wherever, and we constituted country. Or we stole country from someone else by aggression, intuition. We waste our times, whole world wastes our time in such fightings, wars, result of which is always destruction. You may call yourself a winner, victorious, but you are a destructed person. You ultimately wasted natural wealth that God gave us. You killed so many soldiers, civilians, and used ammunition. For what? You also don't know. Neither party that wins knows it, and nor party that loses knows it. In fact, they call themselves winners, losers, but neither is winner. Both are losers, I can say, because you did not bring anything with you from God, and you cannot take anything with you back when you go. Every world citizen must understand this. Even then you are doing this, so you are responsible, no one else. If a scientist believes in constructive work, in electrical production or health or something else, if that scientist works in constructive work, which is good for human society, and also non-human societies, creatures, I think that scientist I consider best forward. And those scientists is always boost and do against humanity, just produce nuclear bombs, nuclear fission they harm earth, they harm humanity, they plan something that goes to kill others. So that scientist work is not with God, because God produced something which you are going to break it. If in your home your fathers or mothers made something for you, and you break that because of anger, without thinking how shall we back again, then you are a sinner, I can say. This is a sin that then we know, you can say, no respite from that. So what I said, injuring about what injuring is not a joke, first of all. It's no fun. It's a serious business. Yes, you can smile, no problem for smiling, no problem for laughing, because sometimes laughing is also very serious. Smiling is also very serious. Miracles are also very serious. Sometimes you smile and laugh because your impression says that you are not laughing and you are not smiling. You are just expressing something. Sometimes you have to teach someone to also use a smile or with certain hand signs, because you can't go against that action. You cannot be angry always. So it's that function, that consideration, that engineering must be in smile, engineering must be in laughing, but with seriousness. It's not like that. If you are not serious actually has very different meaning, which people understand. I don't accept that meaning. It doesn't mean if you are serious you should have different face or you should have different system of working. You are not organized, you are not organized your activity, and therefore you are not organized any activity. There is no direction, there is no destiny when you are not serious. And my serious is not angry or keeping mind like this and head like this. I am very serious, don't come to me. No, that is not seriousness. You have an ambition to go, you decided to go in 10 steps. Those 1 to 10 or 0 to 10 steps are your design to accomplish some job, certainly job, not something else. That is seriousness. From one step you go to 2 steps, from then to 3, then to 4, then to 5, likewise. You go up and up till you achieve your end. That is engineering. In engineering, sometimes you can smile, there's no harm. But you should remember that liquid that you boiled for yourself, it's called tea, and then you are not drinking it when required, the purpose of tea is lost. Similarly is engineering, civil engineering, it's long duration engineering, it's not short duration engineering. In other engineering, you invent something, you design some product, and you keep on selling that and keep on modifying that, because that is complete your design. You can also modify and then recircuit that. That's your mastery. There is no process other than this. So you can say that is different world. But in civil, whatever you do, it affects for many decades. Because work is like that. And therefore, because it includes material resources and all the equipment, etc., we should be serious about that. You cannot laugh for whole duration of project. Sometimes you may laugh, sometimes you may not laugh. But it's up to you. If you are an intelligent person, if you are serious about studies, serious about learning, then there is no question that you should get any stress during the There are two kinds of stresses. One is that the only stress gives you tension and pulling, and there's another one which gives you kind of physical activity. Well, gentlemen, engineering can be defined in every talk we should define. That's not a big deal. You will see dividing because every day I change my mind because of my field experience, practical experience. I can define engineering in many ways, but we have to make it masterpiece definition. It's very important, and that I can say application of mind. Application of minds everywhere. Whatever activity you do in engineering, application of mind and application of resources which are available. This way we say we have all resources with us. With those resources with us, we use them for what? When I see this, I don't say anything very specific. Now, I'll be back on engineering later. Why start with the soil? Because soil is very important for me, which I learned now. I learned before also, but because I didn't find any problem overseas where everything used to go for contracts and we had to do with contracts. That includes from soil foundation itself. So I did not find that standard doesn't apply. The standards available everywhere. And now these are expand. I don't know, company has steps separately. The standards are important, just like life is important. When I say soil, this is a big item, I can say. This is most specific item, I can say. Soil secrecy must be right. It must be known how much deep we have gone or how many foot or inches we have gone since it same time last year, same time last day. We should know that. Soil is unpredictable. Soil cannot be predicted, ground cannot be predicted. Even after investigating thoroughly, we cannot say everything is fine, because maybe on one building you decide for 3 or 4 holes, or maybe on one plant you will decide more and more, and you say, okay, I'll close this one and enter. When I consider soil as my foundation or foundation of foundation, then that soil values a lot. But neither or you will not be understand that. You are very smart. When I say smart, it means something. It doesn't have abbreviation of something. It means your will, your sincerity. When, say, some bad quality work goes on, I feel very upset. I feel not only upset with work or with contractor people, I feel upset with civil engineers. I really feel very upset. And I find that this is their job. They are master of this. They should understand how to do it. Results are not coming out. We don't get results because of many reasons. I am finding these days engineering paradigm for engineers that they want to stay in design offices. They don't want to struggle in life. The struggle side is a struggle in fact. It's an artificial struggle that you have to do it, only then you can get something. When you get something, you have to know that something. Soil is to be understood to a maximum extent. Because this is natural material, first of all we should respect that thing. That this material is very important for both process of construction and also for purpose of future of that structure means its stability for future of that. Sometimes I feel lost because I have to talk and I have to put my ideas behind you. Just like I say soil is important. I say soil, you understand. Without having your soil identity, you cannot work on soil. You cannot think and complain because you passed this subject in your university about soil, and that's the reason the soil is indicatively successful, not originally successful. We have talked to files of soil, structural file and another one. We want to know much about certain soils, that is clay and its minerals. Engineers may be not ready to learn these subjects. We have talked about these soils and now before going for something else, I should start. I hope that you might have downloaded or you might have gone through a video file of these files. If you have not gone through, I would suggest you download this text file as well as you can say this text file and you say without video, without voice, and it's not script.com. Or not script.com, it's live.com. It's reference and which which URL is available. You can see the videos, related videos, and this I come on now. Not to further waste time, let's start talking about this. And before that, let me go to do something. It's also very important. I forget. If you see, I can feed my cow, birds. Let me see that here. let's start. Sorry for delay. Now this file is about now this file is summary now. It's summary, and I already told you author name. This writer for this paper is, as I told you, this is Macaulay Institute for Soil Research, Aberdeen, and Calgary. The author is Robert C. Mac and J. Now let's see summary. It says various types of curves given by Montmorillonite. Various types of curves given by Montmorillonite. Samples are discussed. Says samples are discussed and compared. Possible reasons for differences are considered. Means we are going to study various types of curves from various samples and discuss and compare them, and what are possible reasons for these differences in those tests. Exchangeable cations, which is very important here now. Cations, exchangeable cations, and that is from middle layer, that is sandwich one between tetrahedra or octahedral layers. Exchangeable cations and fixation of cations. You mean to say exchange and fix them. Fixation of cations affect not only hygroscopic moisture, region, but also dehydroxylation region of curve. Dehydroxylation region of curve. So hygroscopic moisture region, that is hygroscopic moisture region, and other one is dehydroxylation region of curve. Reasons for this can at present only be surmised, but eventual solution would undoubtedly lead to clarification of through Montmorillonite structure. This is abstract summary. Now let's just see what actually it says. It says a typical Montmorillonite is usually considered to give a differential thermal curve like that for Wyoming bentonite, WYOMING, Wyoming bentonite, that is curve A. In this file there are 6 curves, curve A, B, C, D, E, F. That is given of figure A. Curve A is referred to. Thus it has a large endothermic peak. It has a large endothermic peak over range 0 to 300 degrees Celsius. Size and complexity of which depends upon exchangeable cations, namely small angle peaks are given by large monovalent ions such as CS+. Medium sized single or double peaks by smaller monovalent ions, and complex triple peaks by peaks of large magnitude by divalent ions and Li plus. This peak system is followed by dehydroxylation, dehydroxylation peak at about 700 degrees Celsius, and at endothermic, exothermic peak system. Endothermic and exothermic peak system at about 900 degrees Celsius. Final endothermic peak has been attributed by McConnell 1950-1951 to hydroxyl ions in tetrahedral sheet. But this does not appear to be a valid interpretation, as size of this peak cannot be correlated with dehydration curves. Evidence, and as shall be demonstrated later, varies with exchangeable cation. Most likely explanation is that of early Millen and McViga 1953, which is also supported by analogy from Cowlin group, namely that it is due to an energy change caused by rearrangement of ions without any water solution. Exothermic peak is due to crystallization of spinel or quartz. That is, exothermic peak is due to crystallization of spinel or quartz. Broadly and Grimm 1951, Arley, Millen and McViga 1953. Depending upon amount of substitution in lattice for a detailed discussion. Okay, see the reference Kelly 1957. Now here let me go to read one more para and then we'll see what does it say. Says over last few years, however, it has become increasingly apparent that there exists montmorillonite in strict sense of term Brown 1955, which gives quite different curves, having either two dehydroxylation peaks at about 550 to 600 degrees Celsius and 650 to 700 degrees Celsius, or only one peak at about 550 degrees Celsius. See Cole 1955, Cole and Hawking 1957. A series is shown as curve B to F and E. FM figure 1. That since that these minerals are true montmorillonites and are not the batholites or interstratified batholites. Batholites or interstratified batholite. Montmorillonite, as has sometimes been supposed, is overview. That is overview from ionic formula table 1. Samples are all undoubtedly dioctahedral non-morolite, and there is no apparent correlation between differences in composition and thermal behavior. That is, distinction is not due to chemical differences. Before going further, I have to also explain. You have to understand, actually, we are talking of endonomic and exergonic. Endonomic, and they say call this, it's a peak. We are saying peak. This is endothermic or exothermic peaks. What are these? Maybe you know it, but even then you have to refresh it. That is, standard sample test. What we are saying, what it's all about is actually, how can we say we are using this term endothermic peak and exothermic peak. This is actually laboratory test. We are making samples, and also we are making standard which we have. We conduct this test in oven, micro oven. We have two factors, two variables. When you see on graphic, when you see plot on graphic, we will find on abscissa there are two options. It is a temperature based or it is time based. So we opt for temperature based, and on Y, or you can say on ordinate, it's differential, change in temperature. Temperature and change in temperature. On abscissa, we can take up to 1000 degrees Celsius, and there is change on other one, delta T, that is change in temperature. There is a sample first. We fix one sample there, and we say we have to fix sample, and also there is a known one that is in relation to which we measure this specimen, you can say. One is test specimen and other is a relative specimen, you can say, in reference to which we are going to measure this. If you see a notation of that, we have to put a line on X and Y, which line say it goes in a straight line like that. When there's ordinate and abscissa, there's ordinate, there's an abscissa. On abscissa we are taking temperatures up to 1000 degrees Celsius, and on ordinate we are taking delta T, change in temperature. Now for that which we know that fixed is there, we are not asking that is sample, that is, you can say, indicative or representative, or you can say that is a reference a reference which we have to compare our test sample, test specimen. Let us use a straight line, any angle, So there are what options we have? We have one sample there, specimen, and one we have test sample. One is a test item, other one is known item, standard item. And there is a straight line on x and y axis. That straight line is a reference line for this test, because this would tell us whether we are losing or we are gaining temperature. Our temperature is more than our reference, or our temperature is less than our reference. We have to prepare sample in lab for purpose of test. And also we can relate it to density as well. So that test sample which we produce and test in this oven, it will increase temperature at various locations, and it depends upon moisture condition, and also upon, if we can say, as we are naming, endothermal peak or exothermal peak, at that content, at that heat effect, if this goes this curve, this curve which you are talking, this curve which falls below that reference line, or it may go above reference line. It may go above reference line. Generally, it may fall below reference line in this case of non-light. Generally, we consider this I'm just referring to you when this curve, our specimen was test we are taking on this curve is shown. In that curve there is a fall from that range, from that reference, or it goes above that. In case this curve falls, our notings or observations at various temperatures up to 1000 degrees Celsius, if these curves fall or remain below that defined range of on a slope line we taken, which is reference line, in that case we can say that if it is above that line, this temperature rises above that. That's called exothermic. Exothermic peak, because that's peak. And if remains below, it's called endothermic peak. And in Montgomery case, generally results state that it's below that, and it's cool. When we are talking of these peaks and we are talking about this experimental paper, we have two peaks we know. Montgomery light relates to endothermic peaks, hardly there is any exothermic peak. That's what I'm saying. I'm referring to that endothermic or exothermic. This is for your information. Now let's go and see this what it says in the start. What it says, we have to see that a little now. You see, if you move on this page 3 or 11, you will find there same depiction of FC signed ordinate on every curve. There are 6 curves shown: A, B, C, D, E, F. If you see, compare these curves with each other. Curve 1 is very different than other curves. B, C, D, E, F. Almost typical, almost having B to F. And A are different. And you can see in A, curve A, on this is, there are 2 or 3 peaks shown in curve 2. I'm sorry, curve A. You can see peak goes even in up to if you think like. If you see this curve A, you will find peak, endothermic peak 1 down, even down this page, and other one is on a little different, it's little lesser than that, and one more is lesser near that line, So these 3 peaks, and also to follow up after third peak, there's some rise, and that one may be called, These are actually shown horizontally, but on real graph, they on your horizontal, it should be like this, as I said, that's a standard graph. It's like that, So these are shown horizontal, you want to horizontal like this. So 1, 2, 3, and after that is exothermic, yes. If you see peak B, curve B, you will find that it is also first one peak, then another one, and then little low peak, and then third one also. While you see B, C, C, if you see, you will find little similarity with little difference in D and C. And same way if you go to D, almost means not exactly much different, but there's some addition of peak, endothermal peak. And then you go to E curve, you'll find little difference, peak and other one, of course these are not different. Of course, you go to peak E and F, you can see yourself, temperature range is given 0 to 1000 degrees Celsius, and there are depiction of 0 to 200 and 400 and 600 and 800 and 1000. But there are further divisions in that, so this abscissa is divided by each, that by 100 degrees, 0 to 100 degrees, 10,000, 1000 degrees. And if you go to this table, it's given that formula for various model light sample. Example. These curves are, monochrome light samples. Ionic formula for various monochrome light samples. corrected for impurities. Now this table gives some information while this curves gives other information. What this figure of this curve say, we have to understand that. It says that differential thermal curves for various Montmorillonite samples. This is A. For A it says this is bentonite. It is bentonite, Wyoming. A is bentonite, Wyoming, USA, and B is low swelling bentonite. So B is also low swelling bentonite, locality unknown, and C is smectite. So A is for bentonite and B is also low swelling bentonite, and curve C is smectite, that is Ameria, Spain, and then D is Fuller's Earth, Dunning, Perth, Shire, Scotland. Dunning, Fuller's Earth. While E is Fuller's Earth again, and this is Scandlu, Canny, England. Then F, this is also Fuller's Earth, and this is Woburn, Bedfordshire, England. So these are serious samples in this course from USA and from Spain, also from Scotland, from Canterbury, and then says England. These are 6 curves. This point we have to understand first. Explanation I am giving here, as that's not very clear in my video separate. Now here's the table 1 after this curve. That's ionic formula for various Montmorillonite samples, and that's the formula. Now what is that? What does it say? We have to understand that point. Bentonite, Wyoming, say USA. Bentonite, Wyoming. Its description is as follows, according to this author, not according to me. It says that points, this first one I am talking, this is bentonite, Wyoming, USA. This is 0.78 m. Then it is plus, and it's bracket Al3.1815, 1815. Then Fe3 plus 0.31. Then Fe2 plus 0.21, and Mg 0.5, bracket close, and the other bracket, that is Si. So these are Al, Fe and Mg, and then Si, this is 7.38, and then Al 0.62, bracket close, O20, bracket OH4. So this is for, you can say, layers. This is for, you can say, tetrahedra and you can say octahedra, tetrahedra and octahedra. So this is octahedra, this is ALF, I'm saying other one is tetrahedra, gypsite you can say. Then low swelling bentonite, this is low swelling B curve, and this says 0.84 m plus, bracket Al 3.15, Fe 0.17, then Mg 0.62, bracket for your that is SI 7.95, AL 0.05, bracket close, O20 OH4S before, say that. Then you go to snack tight, Almeria, Spain, and it says 0.72 M plus, AL 3.25, FE 0.21, Mn 0.01, magnesium 0.77. Then you go to smack tide, you see is the same as I said. Number 3, Almeria, Spain. It says 0.72 M plus, bracket AL 3.25, and FE 0.21, and MN 0.0601, Mg naught. It says 0.77, and F1 1.4. And its further expansion is that is ST 7.34 and AL 0.66, whereas O20 OH4. Likewise, you will say Fuller's and Fuller's Earth ringing. And then you can say in this formula you have seen there's some increase somewhere and somewhere. Let's say fillers are, now there are fillers and fillers, all these three. And it says fillers are FULLER, fillers are Donings, and this is Perthshire, Scotland. It says 0.57 M, and this is L2 and plus L2 0.92, FE 3 plus 0.55, FE 1, FE 2 plus 0.64, and this is Mg 0.86, and in bracket again in bracket SI 7.22 and AL 0.75, 8 O20 OH4. And similarly next is canned blue fillers are England. This is 0.68 M. This AL 2.65 and FE 3 plus FE 2 0.03. Your IS SI 7.41, AL 0.59, O20 OH4, and Fuller's Earth Westbourne, that's from the Shire and England, 0.7 M plus bracket AL 2.35 to 0.34, FE is 1 plus 3 plus 1.05, Mg 0.72, SI 7.64, L 3. So you see, these are compositions of this, and is And you can say, if you read them carefully, you will find that in first three, these are bentonite, low swelling and smack, right? You see, LUs are one goes to increase then decrease, both are there. Similarly here, these are almost little change, but there is change. And then it goes to other one, that is similarly smack tight and all those. If you compare, you can find that here is 0.57 goes up and then it goes further up. Also this 0.92 goes up. Let's see. Let's now move further to see first what happens. It says an analogous situation. An analogous situation occurs in mica series. Analogous situation in mica series that is another figure 2 here, and this is figure 2, I think. Yes, it is figure 2. There are same curves, 6 curves here, and same temperature range, and also same temperature, curves difference, temperatures. Now it says some gastric, sorry for that. That happens with me, what can I do? Says an analogous situation occurs in mica series where typical elite has a peak at 550 degrees C. See curve D and a typical peak at 700 degrees Celsius curve E. Intermediate type, which is such as curve B with two peaks also now which says mica in this says, if you see say peak of 550 degrees Celsius, that's curve D, and peak at 700 degrees in curve E. So curve D is 550 there, and this 550 is somewhere here. This curve D is a peak here. Whatever this peak says, now it says in 550 curve D is here. In 550, that's the peak. Yes, there is a peak, endothermic peak, and also says that a typical peak at 700 C curve E. 700C curvy. Oh, 700, and this is 700 here, 600 is 700 here, 600 is, sorry, 700 is here. So then say in curve D, we know that that's 700, that's the peak. Yes, it's a typical peak of 700C curvy. So in D it is 550 and in C it is 700 curvy, and it's curvy. Intermediate types such as curve B with two peaks also exist. So we go further and see what says. Now in figure 2 it's given here. It's given here differential thermal curves for elite samples. That is shooting on dryness because of heavy moisture. Just try and get it right. Just sorry for the popularity. Actually, I was sweating too much on body. It says figure 2, differential thermal curves for elite sample. This is A, clay fraction that is less than 1.4 micron per from iron ore sample, and white 1.4 micron from from old red sandstone, that is A, clay fraction less than 1.4 micron from old red sandstone sediments. Then Holm Hill Quarry, then it is RD Arrows Berghashire, Scotland, about 90% elite. B, a same material 0.4 to 0.2 microns and fraction over 95% elite, and C is equal to, C gives you same sample and less than 0.2 elite. After that, you say this is C, same sample, less than 0.2 micron, fraction and largely elite, and D is Fithian, because USC, and this is E, this is Baltic. wil ter later about the shire. After that, like this. So in addition to natural occurrence of such atypical minerals, in addition to natural occurrence of such atypical minerals, if it is now let's go further and see a further study we can see in this. These are just the depicted various curves. Alright, now say a 5 now go further. In addition to natural occurrence of such atypical minerals, I should say, in addition to natural occurrence of such atypical minerals, it's also known that they can be prepared synthetically. They can be prepared synthetically, at least for monoilmenite. Synthetical preparation for monoilmenite by rehydroxylation of normal form after dehydroxylation at temperatures up to 800 degrees Celsius. Peak on curve So let's go to this, at least for monolite, by rehydroxylation of normal form after dehydroxylation at temperatures up to 800 degrees Celsius. Peak on curve. Peak on curve for dehydroxylated rotile aqueous material aqueous at about 550 degrees Celsius. Okay, generally let me go right line by line because it's very little cumbersome to understand. It says that peak on curve. Curve doesn't mean that from your X or wherever. It should be an S, I must say. Okay, it's now saying peak of curve for for dehydroxylated soap material appears to be up to about 550 degrees instead of about 700 degrees Celsius. So it has come down from 700 to 500. Davidson 1947, Grimm and Bradley 1948, Hill 1953, and etc. Who are the years up to 1955, like that. I have explained that this shift by assuming that hydroxyl group on oxygen hydroxyl sheets on either side of octahedral ions condense and these octahedral ions condense and resultant oxygen ions lay in sheets of okay, so it comes down from 700 to 500. It says that a same explanation seems to suffice. Says that on the hydroxylation, in oxygen, hydrogen sheets are reconstituted, but octahedral ions remain in their new positions. Same explanation seems to suffice for naturally occurring atypical members. Alright, and we go further and see. Same explanation seems to suffice for naturally occurring atypical members, namely that distribution of octahedral ions and respect to neighboring oxygen. Neighboring oxygen hydroxyl sheets is different. Thus, only 2 out of every 3 positions are filled. Okay, now we move forward, and it is that oxygen sheets are reconstituted, but octahedral positions. Then it's only 2 out of every 3 positions are filled in dioctahedral. It's a dioctahedral here. Form and 3 available positions are not now all equivalent. with respect to hydroxyl ions, where octahedral ions are grouped close to hydroxyl ions. Where you saw octahedral ions are grouped close to hydroxyl ions. One could imagine a slightly tighter binding of hydroxyl groups and displacement of octahedral ions. Tighter binding of hydroxyl groups and displacement of octahedral ions before condensation could occur. Both these processes require energy, and peak is shifted to higher temperatures. In a typical form of molecular light, or typical light, octahedral ions on other hand could be visualized as being now it's very light font actually. I can't read, that's why I feel a little difficult I'm filling on. Both these processes require energy, and peak is shifted to higher temperature. In typical form of molecular light or typical light, octahedral ions on other hand could be visualized as being distributed about oxygen ions, so that hydroxide ions are probably less tightly bonded. And no ions have to be displaced before condensation can occur. Okay, now peak temperatures are then low. Says what could be visualized as being distributed about oxygen ions, so that hydroxyl ions are probably less tightly bonded, and no ions have to be displaced before condensation. Now, peak temperatures are then low. How far differences in relative positions of oxygen hydroxide sheets on either side of octahedral ions affect curve is not certain. Some effects would be expected, and such as cause might partially be responsible for intermediate minerals, that is namely light is old red sandstone, soils and sediments, which gives a peak at about 600 degrees Celsius. And then above explanation. Now this explanation seems rather more satisfactory than vague. Order or disorder suggestion of coal 1955, although he may have had something of this nature. Some more water. So, out 6, I want to finish this file. Now, so says that this explanation seems rather more satisfactory than vague. Because order disorder suggestion of coal 1950, although he may have had something of this nature in mind, coal and phosphine 1957, it does not necessarily require corollary of coal and phosphine 1957. Arguing from similarities with interstratified minerals suggested that atypical Montmorillonites were derived from normal elites. Montmorillonites were derived from normal elites and vice versa. A conclusion which tends to contradict field evidence for Belletter light. Type of mineral may easily be determined by structural organizations of minerals from which it is derived. But elites do not necessarily develop from Montmorillonite or Montmorillonite from elite. Difference are considerably greater than merely potassium uptake or removal. And coal's arrangement must be widened considerably. In addition, it may be noted that the typical mineral is not necessarily most widespread, because in Scotland and okay. What's this? Now this is what says what it says in instructs organizations there is like that a lights do not necessarily okay fine that is in addition it may be not be probably alright, then we go further. This is there's no way not like each relations are all. Now we noted that typical mineral is not necessarily most widespread. This is Scotland and probably Britain generally. Atypical monolites are very much there. And only profile says very generally atypical monolites are very much more frequent than typical ones. Only one profile. Alright, so this is we finish this. Then because it's a little technical and chemical and complicated, Britain generally a typical montemorolite are very much more frequent than typical ones, and only one profile out of several hundred examined by differential thermal analysis at Macaulay Institute contained a montemorolite which might be termed almost typical. Names are really therefore misnomers. Then we go to almost typical. Names are really therefore Muslim. Names are in reality therefore misnomer. By way of wide acceptance of typical curve, it appears too late to make a correction. Now, thermal evidence this establishes existence of a series of montemorolite to montemorolite differences between which may be termed microstructural. Microstructural. So thermal evidence this establishes the existence of a series of montemorolite differences between which may be termed microstructural, not even microstructural, since they cannot be traced from X-ray evidence alone. Apart from such relatively large differences, however, there exist also rather smaller variations which have only recently become obvious, namely those noted during a recent investigation of effect of potassium fixation on Ilmenite curve. Potassium, so noted during a recent investigation of effect of potassium fixation on monolite curve. That is McKenzie 1956. Only a tentative theory to now only a tentative theory to account for observations can yet be propounded, but observations themselves are of considerable interest. It was considered that normal K saturated monomolecular light washed free from excess potassium salts. So normal saturation, you can say, it was considered normal K saturated monomolecular light is washed free from excess potassium salts should give a curve like that for Ca saturated material, but with a smaller and differently shaped low temperature endothermic peak systems. So now we go to with a smaller and differently shaped low temperature endothermic peak system. Index Lysol Center 1940 Bashar 950. In addition to this effect, then we go to point saying in addition to this effect, however, it was observed, this figure 3, that temperature of the hydroxylation isolation peak was displaced to lower temperature from 710 to about 685 degrees Celsius. Then say 700 down to about 685 means lower temperature. Amount of K fixed or rendered non-exchangeable on simply drying such a monomolecule was about 5%. Says that, what it says actually, amount of K fixed or rendered non-exchangeable on simply drying such a monomolecular light was about 5%. Just drying such a monomolecular light was about 5%. Alternate wetting and drying cycle over a period of 14 days. Okay, then we say amount of K fixed or rendered non-exchangeable on simply drying. Such a modern light was about 5 degrees, and alternate wetting and drying cycles over a period of 14 days. Alternate wetting and drying cycle over a period of 14 days cause much more cake to be fixed. Three drying temperatures: 105, 180 and 300 degrees Celsius. 105, 180 and then 300 degrees Celsius were used, and about 35% K was fixed. So from 5 to 35% K was fixed in this case by sample dried at 300 C. Sample dried at 300 C were used, with consequent decrease in the size of low temperature endothermic peak, with consequent decrease in size of low temperature endothermic peak. Temperature of dehydroxylation peak, however, moves back towards that of Ca saturated material, and after 14 cycles is about 700 degrees C. Ca saturated material apparently is not affected by small wetting. Now go further, that is temperature of dehydroxylation peak, however, moves back towards that of Ca saturated material, and after 14 wetting heating cycles, it was noted that for samples dried at 300 degrees Celsius, about 5% of Ca2 plus okay, then it's a problem with that. Now 14 cycles on it. Ca saturated material apparently is not affected by a similar wetting heating cycle, but it was noted that for samples in direct sunlight, let's see what is like that. Alright gentlemen, now we go to similar experiments were carried out by other several remarkable lights, say figure 4, 5 and 6 will see that one. Mechanism of K fixation is not of the comparison. So we see these curves now. Similar experiments were carried out with several other monolight, and see figure mechanism of K fixation is not of consequence, here, and only alteration of curve will be considered. For all samples, progressive K fixation was accounted. No sporia. Mechanism of K fixation is not there in this case, not only alteration of curves. For all samples, progressive K fixation was accompanied by decrease in size of temperatures. AC now causes temperature changes. Now figure 4, this is low temperature endothermic peak system, and this is 4, 5 and 6. This is 4, 5 and 6. Figure 4 here, then it is figure 5 and figure 6. These are 3 separate curves of figure 4 states. Just a minute, let me see how's that. You have to see file down better for suggesting you. Yes, see a file down is better. In this figure 5, I'm telling you the figure 5, differential thermal curves for Kent blue filler surfaces. I think figure 4 I should take first, I'm sorry. I should take figure 4 first, yes, that's okay. Figure 4, differential thermal curves for smack-tight and smack-tight alumina subject to treatment detailed in the FA. Here is, one is CA and others CA, then others K is fixed, and smack-tight and Aris Alma. Temperature range is, I think I should blow it a little better for me to. So I say yes, say yes, no. Say CA, and this is one night, and this is smack tight. Almeria, this is K, it's one night. There is centigrade temperature in 4 nights, and this is one night, and centigrade temperatures. And there are curves, and 105 degrees, 180 degrees, and 300 degrees, you can say peaks on 105 and at then same for K 105, 108, 180 and 300, and also this 14 nights case, temperature range 0 to 1000, and you can see this differential thermal torques, neck tight, and right. So that's right. This is one night number 1. This is one night number 1. This is 1C is fixed and 1 is K fixed. The other one is 14 nights and this 14 nights. And these are thermal costs for smack-tight and Maria subject to thermal treatments. Also, if you see other one, that is figure 5. In this figure 4, you see in this case the bentonite actually a maximum of 17% compared with 35%. But in additional trend can say addition to, I have to blow down this, but in addition to following trends are noteworthy. What are these trends? A, B and C, and D, let's see, a second main endothermic peak at about 680 degrees Celsius is more pronounced when K is present. When K is present, B, temperature of first main endothermic peak is shifted upwards. Says the temperature of first main endothermic peak is shifted upwards slightly on K fixation. C, amount of Ca2 plus rendered non-exchangeable after wetting, heating 300 degrees C. Wetting, heating 300 degrees Celsius is the So bentonite 17% compared with 35%, but in addition following trends are noteworthy. A second main endothermic peak at about 680 degrees is more pronounced when K is present. B, thermal temperature of first main endothermic peak is shifted towards slightly on K fixation and see amount of Ca2 plus rendered non-exchangeable. After wetting heating 300 degrees Celsius, cycle was about 5%. As for yawning bentonite, final endothermic exothermic peak again become more compact. Can blue fast fillers are figure 5 fixed up to about 25% potassium K plus and low temperature endothermic peak low thermic endothermic peak reflects this by showing a greater change than for previous sample. However, the same peak for Ca plus saturated sample and measurement show that about 20% of Ca2 plus has become non-exchangeable. Other trends are alright. Then now before just concluding it, pen blue filler are fixed up to about 25%. That is 25% K and low temperature endothermic peak reflects this by showing a greater change than for previous sample. So however, the same peak for Ca saturated sample and measurements show that about 20% of Ca2 plus has become non-exchangeable. Other trends are that A. Second dehydroxylation peak has decreased in size K saturation. B. There appears to be slight increase in peak temperature of first main endothermic peak on fixation. C. Endothermic exothermic size of cases there is second dehydroxylation peak has decreased in size on K saturation. There appears to be a slight increase in peak temperature of first main endothermic peak on fixation. C. Endothermic exothermic peak is as usual more compact. What is this again? Can the blue fillers? So I sometimes take a little thinking on this. Don't be in different modes because it's very different subject. To read people's writing is sometimes not that comfortable, but this subject demands that because people have worked a lot sometimes and we should use their experience if it's what Just I'm reading this word by word just to understand how much benefit we can draw from this. It doesn't mean they are exact, right? It's experience, it goes on, and can blue filler has fixed up to about 2.5% K plus and about 25%, sorry, 25% K plus, and low temperature endothermic peak reflects this by showing a greater change than for previous sample. So however does same peak for CA saturated sample, and measurements show that about 20% of CA plus has become non-exchangeable. Other trends are: A. Second, the hydroxylation peak has decreased in size on K saturation. B. There appears to be a slight increase in peak temperature of first main endothermic peak on fixation. C. Endothermic exothermic peak is, as usual, more compact. This is figure 5, which we have shown down, and it's that. So this is, endothermic 1, if you say this N down 1 and up 1 both, in K and C both, 1 night and 14 both, 4 nights both, you find that their endothermic is going to be at about 900, and also this endothermic, and this other side, this peak of is blue, this is in 200, 100, around 100 something temperature. It has been big peak. There are all these three temperatures, 105, 180 and 300, as well as here it's also same, while CFX and KFX both I'm talking generally same, and peak is at low temperature, while it's at other peak are say between 550, then exothermics, endothermic, and there's also endothermic seems to be here in case of CFX, and that is at about 400 degrees Celsius, which doesn't access in K as well. Doesn't access in K. Also, this access only in peak in CFX, and that is at about 400 in 105, also somewhere in 180, but not in all. 180 only in this case, or 1 night, not in fortnight. So we have to have some understanding like this. So title of this figure 5 is differential thermal curves. Differential thermal curves for Kent blue. Fuller subjected to treatments detailed in Legion to figure 3. Now finally for Vauban Fuller Fuller maximum K maximum K fixation of about 30 degrees. 30% is well, and reflected in low temperature. 30 degrees is well reflected in low temperature. Endothermic peak, and that is figure 6. Next curve, CA saturated material, however, also shows striking changes, and no less than 37% of Ca2 plus is non-exchangeable after wetting, heating 300 degrees Celsius cycle. At same time, the hydroxylation peak decreases in size, indicating that fixation of Ca2 plus is associated with dihydroxylation, D2 seems to hydroxylation seems to dihydroxylation peak apart from sharpening somewhat does not seem to be altered in size or position on substitution of K plus by Ca2 plus, but appears to shift towards by about 10 degrees Celsius on fixation of K. Now if you see this figure 6, same you find Ca in the same title, Fuller's, and this is K fixation, night, and same for nights, 105, 180 and 300. Temperatures in this scale find big peaks in funnel 4 at about 150 to 150 16 degrees, and here same 550, and also in exothermic peak in 105 at and about 900, and in night other one is, you can say, there are various different type. One in first one is endothermic, in between also endothermic, and at the 900 degrees Celsius. There's not 900 exactly, it is 800 degrees endothermic peak appears. So there are different ways, like this one says differential thermal curves for woven Fuller's earth subject to treatments detailed in Leach X-ray. Summarizing these observations and those for other samples investigated, following conclusions emerge. And what are those? Let's see. Different montmorillonite samples in K plus, though different extents and size of low temperature endothermic peak. Low temperature endothermic peak is related inversely to amount fixed. Says what? Montmorillonite sample fix K plus to different extents. So what it says, summarizing these observations and those for other samples investigated, following conclusions are emerges different montmorillonite samples fix K to different extents and size of low temperature endothermic peak is related inversely to amount fixed. Alright, then B says that Ca montmorillonite with 550 degrees Celsius component of dehydroxylation peak are partially dehydroxylated at temperature as low as 300 degrees Celsius. Dehydroxylated, partial to this, and part of Ca2 plus then becomes non-exchangeable. This presumably also holds for other ions. C. K saturation sometimes affects one component of double beat monotonite, and sometimes other for normal monotonite. It causes a decrease in temperature of main dehydrogenation peak with a slight shift back to higher values on fixation. Fixation always appears to raise peak temperature slightly. Final exothermic peak always becomes more compact on K saturation. A possible theory which may explain shift in peak temperature of normal K monotonite is that K plus ions fit partially into holes in sheet surfaces above OH, slightly loosening binding of lattice. Slightly loosening binding of repeat. Then you can say possible theory which may explain shift in peak temperature of normal K monotonite is that K ions fit partially into holes in sheet surfaces above OH, slightly loosening binding of later and causing condensation to occur at a lower temperature, that is Mackenzie 9/6. In a typical monotonite scale would have little effect because hydroxyl ions loosely bound already. Increase in peak temperature on fixation would then be caused by steric effects due to fixed K blocking egress of moisture. Preliminary results of experiments on normal monotonite, Wyoming bentonite, saturated with other or cations indicate that in general, temperature of the hydroxylation peak increases with size of saturating ions, and that divalent cations divalent cations give a separate series from monovalent cations. These results are in line with what would be expected on basis of above theory, but they will be more fully considered in a later irreversibility at dehydration after alternate cycles of wetting and heating to 100 or to 300 degrees Celsius. Paper of the series paper of the series of samples tested only Li and Mg on light showed confirming results of green colors. Now there are various references in this file on meaning, and there's an appendix that says, let's see that. It seems in this appendix, it seems desirable to add here analysis of various monoclonide samples, and other data available for these samples. Impurities were determined by a combination of X-ray and chemical methods. How it does work? It has 6 curves here. This means 6 samples, and it has what is in that impurities form is given here, and what percentage is there. Let's see now. It's about the no units are shown on either axis, no problem. It says SiO2, that is first one, SiO2, TiO2, Al2O3, Fe2O3, FeO, CaO, MgO, MnO, Na2O, K2O, H2O plus H2O, and then down is some, and then down is C dot E dot C, and M dot E, and divided by 100 G. Now again I say, because in then there are 6 columns after this, 1, 2, 3, 4, 5, 6, and these figures are given, and all are then added up, and at end there's a result. So let's say what it says then. Because title says, it seems desirable to add here analysis of various monoclonide samples and other data available for these samples. Impurities were determined by combination of X-ray and chemical methods. So let's say that, what's this? SiO2. Like to see whether I come back after this, whether I check with my friends as well. I'll take water then. Alright, let's move this way. It's very actually interesting one if you see this one. Oh, now this is a comparison entry for X-rays, which is which through X-rays and other chemical samples were determined by synthesis of various monoclonal samples and other data available for impedance were determined by a combination of X-ray and chemical methods. So as I said, SiO2, there are 6 columns, and this is SiO2 1. I will say numbers and then I will speak percentages. SiO2 1 is 54.55, 2 is 68.56, 3 is 47.7, 4 is 55.1, 5 is 48.21, A6 is 50.30. TiO2 1 is 0.21, 2 is Tr, and 3 is 0.25, 4 is 0.30, 5 is 1.32, 6 is 0.15. And Al2O3 1 is 20.12, 2 is 14.17, 3 is 21.59, 4 is 21.36, 5 is 15.87, 6 is 14.86. Then Fe2O3, this is you can say FeO3, this is 2.23, then 0.2 is 0.96, and then 3 is 1.53, 4 is 3.18, 5 is 6.48, and 6 is 8.86. And 1, this is FeO, 1 is 1.48, 2 is not, 3 is 0.00, 4 is 0.20, 5 is 2.45, 6 is 2.07. And MgO, 1 is 1.99, 2 is 1.72, 3 is 2.82, 4 is 2.51, 5 is 2.18, 6 is 3.06. Then MnO, 1 is 0.01, 2 is 0.00, 3 is 0.07, 4 is 0.00, 5 is not given, 6 is 0.00. And Na2O, 1 is 2.48, 2 is 0.23, and then 3 is 0.18, 4 is 0.92, 5th is 0.12, and 6 is 0.00. Then it is 0.31, 0.37, and 0.420. Okay, now we go to, sometimes data is very small. Na2O I said, then we go to Na2IC again. 1 is 2.48, 2 is 0.23, 3 is 0.143, 4 is 0.92, and 5 is 0.12, and 6 is 0.00. K2O is 0.31, 2 is 0.37, 3 is 0.20, 4 is 1.48, 5 is 0.57, 6 is 0.04, H2O plus, and 1 is 4.74, 2 is 6.19, 3 is 7.07, 4 is 4.9, and 5 is 5.12, and 6 is 6.20. Then we can say this K2O, 1 is 0.31, 2 is 0.33, this 73 is 0.2, 4 is 1.48, 5 is 5.12, 0.57 and 6 is 0.04. H2O plus is 1 is 4.74, 2 is 6.19, 3 is 7.07, 4 is 4.90 and 5 is 5.12, 6 is 6.20. Then H2O 1 is 11.3, H2O 2 is 5.61, 3 is 16.65, 4 is 6.82 and 5 is 17.57 and 6 is 15.09. So you can say that highest R in XLH is greater than the highest. When we say these figures, all 6 columns, sum is like that, is all in here. As you see, sum is column 1 is 100.37, column 2 is 100.66, 3 is 100.52 and 4 is 100.67, 5 is 100.1 and 6 is 100.93. After that, there's a row that's 6.E.T.C.M.E divided by 100 G gram. So result is 80, and then what's that actually? C questions that. That's not clear here, but result is 80, 69, 88, 49, 86 and 91. Then we go to imperialist percentages. Let's see what that say. There is again 6 columns. There are 1, 2, 3, 5, 6, and names are quartz, upper line, SiO2, feldspar, kaolinite, sphene, anatase. Now let's understand what it is in 1, 2, 3, 4, 5, 6. Quartz, no, so column 1, quartz is, you can say, 8.5, column 1, opaline and silicon are not given, and column 1, feldspar 8.4. So we can say similarly to quartz is 5, opaline is 25.5, and SiO2 is not given, feldspar is 9.7. N3 quartz is 2, feldspar is 5, kaolinite is 5, and sphene is 0.06. N4 quartz is 3, and feldspar is 32.6, and sphene is 0.7. 5 quartz is 4, feldspar is 4.4. Come on now to the one, let's say bentonite, Wyoming, USA, that's 1, bentonite, Wyoming, USA, 2, low swelling bentonite, locally unknown, 3 is mactite, Almeria, Spain, 4 is Fuller's Earth, Duning, Perthshire, and 5 is Kent Blue, Fuller's Earth, Bear Lead, and for Fuller's Earth Downing Birthright, and 5 is Kent Blue, Fuller Earth Bearsted England Bearsted, and Fuller's Earth 6 again, that's for England. Analyst number 1 KR Farkuras number 2 6 JB Craig. Sample 1 was in its natural state. All other samples were saturated with Ca2 plus before analysis. So 1 was natural. Impurities indicated have been taken into account in calculating ionic formula in table 1 in text. It has been assumed that all non-exchangeable Na2O, non-exchangeable NaOs, and K2O2 and excess CaO is accommodated in feldspar and other TO occur either as springtime analysis. Author desires to thank Mr. W. A. Mitch for supplying X-ray data. Interventions. Well, I think it's not, I don't know what does it mean, intervention in Nova amount 6 is not in English. I can't read this. Maybe this is something related to, I don't know, snaring. It's also not in English, in some other language. So I can't answer this. Also, what we have actually gone through in this file is, this is actually, for my understanding, this is interesting research by some people. Interesting in the sense that it holds you to think about something, and that it holds you this thermal curves, this Montt-Morley differential thermal curve, general variability of the hydroxylate region, general variability in the hydroxylation region. This is really interesting curve, I can say, and in a way we have gone through summary. And summary, again I just repeat so that we have gone through complete file. What we have gone through this summary indicates that various types of curves given 653. I think I watch time. Okay, no problem. Various types of curves given. Various types of curves given. By Montt by 650. Okay. So various types of curves given by Montt-Morley samples are discussed and compared. Possible reasons for differences are considered. Exchangeable cations, and fixation of cations. So exchangeable cations and fixation of cations affect not only hygroscopic moistures, affect not only hygroscopic moisture region, but also the hydroxylation region of curve. Reasons for this can at present only be surmised. Alright, so exchangeable cations and fixation of cations. Exchangeable cations and fixation of cations affect not only hygroscopic moisture regions but also dehydroxylation regions of curve. Reasons for this can at present only be surmised, but eventual solution will undoubtedly lead to clarification of true moisture conditions. Then a course description says typical month mortalite is usually considered a differential thermal curve like to that for bentonite, because it has a curve A, which is a large endothermic peak over range 0 to 300 degrees Celsius. Size and complexity of which depends upon exchangeable and well, we can say it is large endothermic peak over range to 300 degrees Celsius, and size and complexity of which depends upon exchangeable cations. Only small single peak are given by large monovalent ions such as Ca plus Cs plus, medium size single or double peaks by smaller monovalent ions, and complex triples peaks of large magnitude by divalent ions and halide. This past system. Well, we can go through all these files now. All these A, B, C, D, E curves are there. You can see B to F and A. There are different properties available there. You have to read this file. You have to understand this. It's because of dehydroxylation regions. We have to understand endothermic and exothermic peaks. We have to understand in this, and what is interpretation of these. If these are, as I said, this peak, these are endogenous, I guess this that's very important point. So we have to actually work on such systems as part of thinking. We cannot simply say these guys have done good work, we should understand. Same time we should interpret these curves also. That's most important. Just like I said, in this 5-6 curves A, B, C, D, E, F, 7,000 degree, and if you see in all curves, there is except in one one is having two peaks, endothermic, and others are having, but little one is bigger one, some not that big, and all like that except last one. So by this peak you can understand. Means you can say which is baseline. That baseline is called specimen, which you fix for comparison. No stress specimen, other one which is relevant one, means you already know about which I know this fixing that, and you can very easily understand it's about or line is whether your curve is down or up. Which is down, which down is this change of temperature is downwards, means this is not upwards, means it's below that sample. So this is endothermic, and other one is upward is higher temperature. So what happens to water, what we can understand is since Mount Morlite is a clay mineral that gets water and swells in. So when it's endothermic, means you can say it gets water because its heat energy is reduced and water can't be replaced. Moisture increases. This is wherever this is about reverse case will be different. This one is curves indicate all those curves. You have to go through these curves, only then you can understand what it is. I think well more than this I may not be able to explain to you, because you have to understand yourself. You have to understand this curves yourself. No one can explain to you why you want to explain. Kind of this. Once you get into this, means basic is required to be understood. I'm explaining word by word for purpose of just to understand, because this subject is not like a dynamic study. Soil cannot be studied in a dynamic way. You have to study it with thorough understanding. And likewise, you can say we have here. We have here to close this file now, and we have to understand what we have learned so far from various files. We have gone through, for your information, we have gone through, this granulated blast furnace slag in engineering behavior of stabilized soil. We have gone through that. Effects of, we can say, this is we have gone through this. This was effects of granulated blast furnace slag in engineering behavior of stabilizers of soil, and also we have gone through soil resistivity, ground soil resistivity, and stabilization, bitumen stabilization. We have gone through control stiffness columns, ground improvement, service ground developments, and also deep soil mining mixing. We have gone through that method. There's ground improvement, ground development, and also electrical soil resistivity and definition and measurement of soil resistivity, circuit globe. And we have also gone through hydraulically bound material, HBM and cement bound granular material. Of course, we have gone through lime and cement stabilization, contractile or whatever ground development. And then we have gone through this monolite microstructural analysis and magnetic characterization of native and magnetization, all that, and also monolite differential thermal. Today, general variability of the hydroxylation solution and monolite and introduction to properties and utilization, also soil modification, filtering ground development, and soil modification, stone columns, reverse thermal saturation and wider stone column. Yeah. We've gone through these files, and these files are very important. I will also bring to this some more files that are related to you can say soil exploration methods, because these were specific properties related to soils which is handle soil. Now we'll get into soil exploration, for which I hope I will be able to get some reference files, maybe one or two, not more, for purpose of your projection. We'll talk of them about, because until we don't understand methods, because my aim is, my objective is to let you understand about reports that I'm going to project, my reports for one project major and some reports for some other projects which you have in files. I suppose I have put them to those files. No, before that, I close this soil now. Today my soil is only up to this point, but in general, I'm stating that soil is not limited to what I said. It's not limited to that. Soil is directly related to, the watering as well. Maybe the watering is done better. I have already discussed this. Yet common sense has to apply onto that. We have discussed in various other Qatar documents. Maybe I don't know you have gone through that or you have not gone through that, but based on experience, and particularly where I'm not talking of sandy regions, I'm talking of both sand regions and clay regions, because we are talking of stabilization, we are talking of properties of soil, we are talking of the hydro oscillations and hygroscopy, all that, which directly, see, to talk in laboratory or to conduct tests is one part of job, that's part of research. That gives some input, that gives some guidance, but to apply the recommendations and failed, it's not proper way. It's not a way that well speaking, if you learn that or know that, what happens? You speak to them, they listen. If you want to, excavate in a substrata that's full of clay soil, suppose you have to excavate complete When you think of excavation in clay soil and you know geometry of borehole, what that says, you know sections of borehole per report, and maybe you have 2 or 3 or 4 boreholes back for that underground work. You also have drawdown curves there according to requirement. What's drawdown there, what's position, what's stratification is known from while conducting these drillings and taking out samples, also what are this world of soil. That way, you must have some kind of soil report, and you should understand that. Soil report may give some surrounding buildings only, not more than that. Topographically, you can say, topographically or geographically, in this location, these are, let's say, related survey identifications. That's not necessary. You know that when you go to site, not necessarily have to soil report. Soil report gives you bore logs and also some more information about it. That's it. But that is also one part of this issue. We cannot certainly depend on exactly what's given in soil report. We have to see ourselves. When clay soil means it's something dangerous. Clay can be modular. Generally, can be. I've seen it is multiple combination of montmorillonite or perlite and maybe some other parts, particles. Advanced nature means you cannot analyze everything inside. You have to take into consideration circumstances, levels of study. Even stratification is not regular. You will find your bore logs informations accessibility varying from place to place. When you take soil, I say start from one. You say 1, 2, 3, 4, 5, 6, 7, 8. When you start sometimes just to see what's there, you shall certainly understand what sort of soil is that. You shall certainly understand that it's moist or it's dry. And you shall certainly understand it's collapsing when you excavate. You excavate manually or you excavate using excavator. Nature of soil will tell you what it is. And you know it that you have to provide dewatering methods there, and you will chart out that plan that you have to do it. So you will excavate, and then you cannot immediately do benching, but ultimately, so you have to go 10 meters down or 15 meters down below ground surface, which requirement is your design. And so you cannot say there's no requirement. This design is 2 years or 3 years. Yes, 6, 5, 6 years. So you also have sort of something. The layout, you start excavating, getting new working areas, and exactly in 1 day you can't excavate. It take 2 days sometimes, so 3 days, depending on how your machines are enter there. That's okay, but problem is in clay soils because porosity is very high. permeability is very low, and these particles are very fine. If montmorillonite exists in those, so refined vermiculite may not be that fine, and let's say carbonite or let's say whatever else may not be that much stronger or finer. By experience we have to observe and understand what that soil is on site. You cannot go for laboratory reference for every activity, and that's the reason that we are differentiating between research work and operation or activity work. In research, a lot of time is there. For example, 14 days specimen founders you can do, but on site you don't have that much time. If you say 14 days you will bet, means you cannot do that contract, means you do not know anything about site. You have to excavate and do concrete immediately. Keep that in mind. It's not baby job. It's a product, and it's time, it's cost. It's not research work. Research work is only for your, theoretical knowledge, creating theoretical knowledge references. But keep in mind that you have to direct site or implementable people. They have to keep in considerations every point of view. They have to chart out total method how to do that job. You mean to say excavation method statement simply saying the explanation of excavation which requires continuous dewatering. Continuous dewatering, that's very important, and that's related to soil, that's related to everything. Because if you don't understand your soil, and you think somebody would come on site, careful government, to tell you, this, can I find myself? This never exists. When you start excavation on such, so I'm just giving a reference, I'm not saying this, yes, it's a part of whole soil, it's a part of soil, it's little soil. You'll be lucky if you don't get soil, clay, you're lucky if you get sand only. Because yes, sand can collapse when it's dry, indeed. The excavation collapse, it doesn't give you some, but it is not that harmful for our soils. So when you excavate that, you start excavation. Let us say it's first. Let's say it is sandy soil, some dry maybe, some wet maybe. You don't know, but when you start excavation. If it is water table high, maybe after 1 meter you start getting water flowing in. And there will be soil report is there, but even then by trial on site, that. So you have to change your access style. You have to be ready for that. If it is only soil sandy, then water flow is not a problem because it's a permeable soil. It's not, it's not porous. Water can flow through this soil. The voids are high, but they're all connected. There's no interlocking between them, probably. And there's no cohesion among those particles because of some soils. So there can be something, say, contour silts is going to work sometimes, or you can, and out. Silt is different type of soil. Now, in that case, when you keep trench down, you're going to excavating. You have to arrange at every depth you go some type structure. Not structure, it's not structure. Sometimes some pit is called some pit, SULP, some LP pit. At some corner, this corner, of that corner, diagonally, opposite corners, so that when water accumulates in that deep, some maybe lower than your formation level, and you have to provide submersible pumps into those pits so that when water is accumulated, you pump it out. And this is continuous operation. It doesn't stop because water can accumulate anywhere. This must be a thought pen. So you provide these submersible pumps in those, and these submersible pumps continuously draw water out. But we have to be careful. One point that, yes, we are going deep down than formation level, deeper than that. But we should keep in mind that there will be other buildings around, other pipelines around. How fast we should go for that. The function is not to draw water out. That's not our objective. Our objective is one only, and that is that to keep our area dry, this area of foundation dry. We have to keep it dry, and in that dry area, we should do foundation concrete, and then we gradually come up until we reach up to water table level, which may be at ground level or it should be below that. Once we get up to water flow level, means after that, we are free from that problem. The water should keep there moving post construction also. You can't restrict that. That's the beauty of water. That's the purpose of the water rotting that happens, and because you take out water access, it can cause problems in foundations of others. So this is that. Same thing you see when you feel that you have come into level, your wall is up or your structure is going up, and you start complete structure, cover it with waterproofing membrane, and then production. And also, second point, the first one I told about, which is very common in deserts, but also in deserts there's another one, clay, which actually is problematic, and if not exactly Mount Model like Calonite or something else, then you have to think a lot. It's not easy, difficult. Yes. Difficulty is that excavation itself is difficult in those portions. Because first of all, clay doesn't collapse immediately. It takes time, it's cohesive soil. It binds with each other, not binds, but it's overlaps like that together. So you can excavate that, but when you know this clay, there is water there, then you have to make a plan. It's how should I excavate? You have to, if say 10 meters down, 9 meters down. It's a question mark. It is 10 meters or 15 meters down. You maybe have to construct some structure, say water tank in the ground. When you go down in benching way, you have to provide benches on that side. 1 stage, 2 stage, 3 stage, like that. And each benching is independent. This benching means you have to excavate more for benching and for working area. And then you can say, So a couple of days you may take in that excavation of clay soil, and a couple of days you may take in excavation of sandy soil. You have to keep an exact watch of what you're doing. You have to provide supports on both sides if required, and you have to ensure that people walk on those, your pumps and headers was connected to those high duty pumps, and you have to ensure that water does not go as mixed on to store filtration. And the water was sent for circulation or for whatever purpose that is required in water. And dewatering is continuous. Anything it continues and water levels are down or water is not coming in, and you can prepare for condition. Don't take falling. Falling heavy, I don't have already informed, but you have to recall them, please, are doing this, and so you cannot wait that area should be completely dry. That happens, but it should be free from water flow. Then you have to compact it safely and don't get dry, but foundations are definitely. Point is not very critical, very important from that point of view. That's why I want to talk about dewatering. I use dewatering longer because 82, I think, 84 is there, I don't remember. It was done in clay soil in Mahmoudia, Baghdad. We had, I think, 5 pumps or 3 pump stations. We drove around 10 meters depth or more. We excavated 3 benches, and Miller pumps installed the bench, and well point system we used for this purpose. Wells which are connected every 1 meter or more, this ranges, and all are connected to your system pump, Miller pump, or whatever pump you use, that's what we use. Continues for many days, people were not clear as how to do this, it's not getting out of control. They were not able to. This was it. Purpose was the foundation. Once you do a foundation, the foundation was rafted in that case because of clay is weak bearing capacity. Therefore, it was raft. So what we did, we had to do at night, and we just kept it at clay and keep everything ready to raft foundation. And all whatever is required, membrane placement and shutting out everything. And we did that. We successfully did one draft, and then other drafts of canvas. We had to do that without. There were many warnings from engineers, from government as well as be careful. You don't pull small, fine particles. It's clay. Then can be fine particles like one more like dangerous one, which can come. Though it's not turbulent flow. It's a little between turbulent and laminar. Its number may be different. They're not numbered, but there are possibilities because there are buildings nearby in vicinity. Good buildings, residential area. He said there are possibilities based on success readiness that there are possibilities that you may pull those soil particles, microparticles. We are talking here this microparticles in this clay milled samples. This can be pulled in, by your pump. So you have to be careful. They should not come not only from your area, or maybe this distance 50 meters away or 100 meters away. Some building, maybe because it's clay, so possibly that may be clay. We cannot say, but we have to keep in mind this factor. And your water should not continue for so many days that water also comes in. Don't wait for the soil is 100% dry, because we cannot take that kind of risk which is expected out of such work. Because in case we pull that smallest particles, you may say maybe 0.0001 millimeter, possibly 0.001. So it's like flowing material, means I think water is heavier, much heavier than that particle, and water can dissolve that. Water can dissolve that because of chemicals in that morolite in that, and that dissolved water can contain those particles, and you are taking and sucking in through your well points those particles and pumping out through your system, and then disposing for environment protection as well. So you have to understand what was drawdown curve, what will be discharge, shall it be turbulent or not, will it be laminar, or should be somewhere in between. And accordingly you have to seal if water means you don't go too far to blow to draw that water out. Means you have to assess yourself whether situation of formation level where you have to lay your concrete or prepare for concrete is well enough, means it allows you to do your foundation work. Area is required dry, but you cannot keep so dry that other structures are also affected. Because you pull water out, that area sinks, it can sink. Not a field sink because you are throwing water from that. You can see dehydroxylation, the same thing, the hydroxylation happens, and that can cause a problem. Means it's not a question of heating here, it's cooling here. Means water is out, that person loses temperature below that building and causes a problem. So means we have to ensure that formation level are qualified at that time, that we can compact it, or we have to lay, you can say, granular materials there rather than, and then compact, because it's difficult to compact soil that water comes in. So replace some material, or of course excavation includes that, and place some layer of concrete, dry concrete, and then blinding concretes. Of course it will take 2 or 3 or 4 days, 3 days possibly, because to lay all your shuttering work, formwork and steel, but it takes some time because you are ready with everything. Fabricated steel is ready, fabricated shutters are ready, ready-mix concrete is ready. Though there's no electrical services in that, nothing, because of conditions of work really. Electrical industry was not taken, embedded one in such cases, and they have to take super, from ground above. So we have to be very vigilant on that for purpose of doing concrete. And once you place raft and its entire changes, water cannot come out of that. It may be around saw or drop, but not from below. And when raft is laid, then you have to start wall work, certainly, because walls are RCC, and this is whatever column is there or whatever is there in between, the its tank and the structure is there, whatever superstructure, this columns of a raft, and then you have to move further, and side by side you have to apply concrete walls and remove their shutters for application of soil concrete protection of surface, vertical surfaces. So that's only way I'm going to say to control that activity, to start concrete in clay area or to start concrete in your sand area. And that's why this water dewatering and your knowledge of the soil do work in such cases. And these are, you can say, you can say, very reliable, reliable works and must be accordingly respected. And I understand it was that time. This was, I think, 82, 82 or 83. Yes, I was there for a very brief period. I didn't like that job due to some reason. I had to move out of that. But this activity, I was involved in, particularly this activity, and in joint collaboration with client's engineer. I still remember his name was Dawood Christian, and you can say I also wrote some notings of that, but I lost somewhere how we did that, each point we did, how we interacted with our staff and those people and government people and all others. I had noted somewhere in those days and gave to some of my junior just to have a study of that. And that person didn't return me that because I had to leave. Maybe he didn't like it or liked, I don't know, but I lost that paper. It's a good paper in those days, handwritten paper. I took at least, I think, many days to write my observations of what we did there. It's good record for me for my future. Well, no problem. If you lose something, doesn't matter. You lose your mind memory also. And it's a good one. Means I appreciate myself there. Being my age, with considering my age, I'm 82. You can say. 82 means 52. About 28 years I was, maybe 28 or 27 years, young, dynamic, aggressive, crying, shouting engineer I was. And really people did not like me, to be very frank there. Just personal comment I'm giving because of my aggressive nature, because of my, going behind people all the time. I was in good position, I could sit in office, but you see, sitting in office doesn't solve problems, which are site-related issues. And in those days, all systems did not exist, just like we have today, quality system, planning. We have to do ourselves. Means whatever system you have to do yourself, whatever procedure you follow. Means there's no organized system. You can say these systems. We have to do many systems, but quality is not according to those systems. In those days, there were no many systems, but quality was perfect. If you meet some person who worked in Iraq in those times of Saddam Hussein, you will find that person horrible in quality. And actually, to be very frank, quality, I understood there only what does quality and workmanship means. Really, I can say that system in paper is something else. But when you work on site, and particularly in such situation where you are, you are in such a situation when you don't get any help from someone else, you have to decide on your own. There will be no one because people did not know that type of work. And in those days, everything was, something extraordinary. You could not experience that in my country, particularly when I was part of government service. I can say that before that I was in some buildings project, high tower, RCC Fairfax, and how tough learning that was. I had faced problems there as well, many problems. Because my experience was not extensive. I was not very well experienced there. I was just normal person. But handle. People used to say it's very tough person because I was beaten by management in sense, not manager, but while you do some mistake or somebody does mistake, keeping yourself in dark, and you know that causes big problem, big issue. I'm just trying to reflect how life moves like this. Because I am talking to you about soil, and soil is really, I understand too late. I understood too late when I studied my degree. I did not take much care for soil. It was my subject, construction and foundation engineering. And in construction and foundation engineering, soil is a must. In that construction foundation engineering, you can say half was construction and half was soil. But we could not have a solid idea that time. Soil is that much tough. Because when we used to go to sites and we could not understand on the side we were working. Yes, I was a degree engineer, experienced, but a degree or diploma or other, this do not matter. Once you are on site, this does not matter. Because you have to decide how much you can consider on site. You don't have every report. You don't have soil investigation report. You don't have some other report. And even if it was done somewhere here, who's with whom it is, and how many years back that project was what, means the soil ministry was done. That was not computer age. That was manual age. Even if there was soil report, means where it is, who caption, and project has been running for many years now. Where will you get from, and maybe why you want this report? And we have no answer to say. So I say, what do you want to report? And that's maybe written and typed or something. No, photocopy in those days, or no computer. This is life. Is that you have to see some document. You will know. You have to wait for days or for months, and by that time, your project will be done wrongly or rightly. This happens. It was time, when there was no mobile pumps in common mobile pumps of concrete. I'm talking in that time when I was there in Iraq, 1982. Yes, I used this pump. We take pipes, join pipes together, and root we take. Means no mobile pump. You have to do a stationary pump from which you have to make a route every time. It takes time. Means you start from that pipe and try to take it through whatever route you take to your location, and you change location every time. Yeah, still this is done in our country, yet mobile pump is not very commonly available. That time were available, but means every contractor could not afford that due to its cost or non-availability. So that stage I am talking. Now mobile pump is very common in those countries. You want whatever number of mobiles and whatever specification of that mobile, access of that mobile. Means you can even use sometimes 2 or 3 mobile pumps together, and we did that. And you are pouring thousands of cubic meter, 500 cubic meter, for example, and area is 2 or 3 pumps, so you can use them. You can say even foundation concrete you can do comfortably use of mobiles pumps and mobile concrete pumps. Talking. So it's dynamic now. You can say it's fast tracking projects these days. Because fast tracking also causes problems. Sometimes I understand when I was in one project, an LNG plant in Doha, and I joined. They were doing LNG foundation soil improvement. I saw that myself, and because it was LNG tank, big capacity tank having about, you can say 80, I think 50 meters dia, yes, 50 meters dia. I don't exactly remember. This is a big tank, 50 to 80 meter dia, and thick walls. And walls RCC containment height was more than 50 meters, and there was one cupola on that. That was not done that time. They were just doing foundation work. There were 3 tanks. They had done structures, but 4th one they are doing that one. I saw the units. Soil improvement was ongoing because this was sea, and soil was bearing capacity was not very supportive. Maybe there was some sailed or climates in that due to location being adjacent to sea. That was a possibility. I did not go through the reports. Nobody showed the reports, and I also did not ask the report. Had I asked, I would have given the British was project manager there. So that was not refused. There was interest in such people, demand papers, know something or suggest something. And that person asked me a question, which means, how do you feel quality here is? I said, well, I appreciate it. It's better than I seen somewhere else. I was very impressed. They were doing better work, so clean work, and according to system, according to rules. And then I saw they were talking of soil improvement, testing of bearing capacity, which they achieved on improved material. They were talking of K factor and this factor. I asked K factor means they were saying, oh, it's okay, we got this much. But they could not reply me. Also, the American Lebanon was there, can reply. What K factor is that? Well, means I got to know that soil improvement is done on that tank because that tank is very heavy. Its structure itself is heavy, and there's a containment in that. Also, there's a tank in that because that gas remains in minus, I think, 80 temperatures, 60 temperatures. So that's the internal tank was metallic, while external containment was for safety reasons. If suppose there is a leakage, tank oil in the gas should not come out, it should remain there. So within containment, that was purpose of that. Yeah, I have that somewhere. I'll show you if I'll show you that file somewhere. Maybe say I'll show you. That's no problem at all. I say that just like that, and that is quality work actually, because these are pre-stress tanks, and soil improvement was there, and stages of lifts were there up to 5 meter stage by kick, I think kick jump in terms of form of it is it moves like this, on wall, and you need not fix it from below, just jumps, and that is the concrete, and they lifted cupola prefabricated structure, steel structure, which is meant for permanent shutters. They use the air, compressed air to lift that into that height. And there was a cantilever platform extended from there at cupola. Many times I move on to that. And I was not in charge of that project, but just tried to get some information and how they cured that. Means they provided proper plumbing system for curing itself onto circular tank inside and outside. Means we have to understand all these points. It's engineering, it's no joke. Every project requires some operational research or activity research, you can say. You cannot move blindly on anything. You have to devote something to someone, and that was there. That was interesting one, of course. I should not say no. That was interesting one, and I also had interest in that. Then there was another one, beach villa nearby, that I have to be there as a coordinator and project manager for that project. I used to issue all drawings, to coordinate all information of architecture, structural services in that. That beach villa, it was called big one near sea, adjacent to sea. And foundations already they had done. They are doing roof work, slab work, all that. So it was Hardy system, Hardy, H-O-U-R-D-I, Hardy blocks, which I never knew what were. But this is nothing on the name. These are, actually precast blocks of trapezium section, trapezium and the hollow blocks, so that, what actual intention is. They want to produce a flat surface below slab, not suspended beams or something, or drop beams, you can say. Beams are there in that, but beams are drop beams, but practically these are not drop beams because these blocks are put on shutters, and there's a gap between these blocks, and these are beams. Once you open the shutter, you'll find complete flat surface because Mini beams are there, and these hollow blocks were used for purpose of passing electrical pipes or some other pipes, and top of that surface was later cast in thin layer, and which was transformed into diaphragm action according to the requirement of slab. So we say our slab or our plate is diaphragm, and so they had a system of diaphragm. You may call it hidden, not hidden actually, beams are there, but at many of very close spacings, and these are thin beams they used to cast. Thin in a section is small, but holy shuttering, holy blocks are there forever. Little complicated services are, because your pipes have to go through them, but you could put these pipes in top layer also for purpose of distribution while through these beams. It depends on electrical engineers, but that's, of course, it takes some time. It's little complicated, but those people like that. We don't want to see this beams down, and we want flat shuttering. We don't want to do here's a beam shutter and this complete simple shuttering quickly it is done. So it doesn't take much time for shuttering. Only for stairs, you can say it's different. In stairs, you can't do that in the stairs. Stairs or lift, where lift is the for sure, you can't do in lifts. But for stairs, it's not allowed. Otherwise, means for everything else, so you have to do that. It was done. Means I can recall that. Still very old, but just like that. Now it's that. It's around. My purpose was just to let you know what it was. Though it's soil today, I wanted to talk about contracts also, but now it's too late, and around 8 now, and it's already 4 hours, around 40 minutes I'm going to be. I cannot continue for 5 hours, so it was too late. No problem. At least something is better. Yesterday I lost my video on Facebook, as I told you. I don't know how it happened first time. I wrote to them, but still no answer. Well, I lost though. I was lucky I put one same video on YouTube. Today I'm not doing that because it affects my dongle battery heats up a lot. I'm doing on Facebook, and let me see if it stays there. It's also lost. That's what sometimes you see. Actually, what's happening? They are producing a new Facebook on that, and they just publish the news without even doing complete work on that. That's a bad one. And let's see what happens. How does it work? It's also to be seen. It's also very important for everyone of us. And what I should say, soil. Again, I would say soil. I'm very interested in about soil, though I'm not 65, 66. It doesn't help me, but knowledge is knowledge. You be 66 or 65. Soil is very interesting subject. It's very boring, of course. Always remember, boring is very interesting for functioning. Medical science is very boring, but what's the value of medical science? Engineering is also boring. What's the value of engineering science? It depends, means how much it's your interest. If you want real knowledge, you have to be serious in subjects, and you have to see applications of those every time. That's very important point. You have to understand each time. And if you cannot do that, then you certainly lose something, and that losing something is very problematic. My purpose was for some knowledge of soil, and now that was some research work I procured from here and there through search. But now later on, now my actual purpose is that I have to talk something on soil exploration, very elementary, and then we have to project to you soil report, 1 or 2 that I have, for better understanding of soil in real world. Though these reports are not these are old reports, old or not old, reports are reports. I will go slowly also on that because this is practical, and once we understand all parameters about soil, we can understand those reports as well. That's only my purpose. I have to do that, and then we see how fast can we move. And I am sure if you little cooperate with soil and these videos, which I have given many videos till now, about, you can say, more than 500, and not all engineering, it is other issues as well, but more than I think 200 related to engineering. Varying times means some up to 300 minutes and some maybe up to half hour only, but all based on my practical experience, not theoretical. I'm not interested in theory. I just want to share with you guys, you respected colleagues, about practical work, which is more beneficial, because future is not in designs. To be frank, future is not in designs. Future is in site work, because quality has dropped very badly. You have to lift up quality. Otherwise, if you want to respect design, you want to earn design for your respect, for honor for your design, then that design must be implemented, and that can be implemented only when there are responsible engineers on site. And if there are no engineers who are responsible, who respect quality system, or who don't understand quality, then you cannot say your work is valued. Your work is not valued in that case. That point you must understand. Otherwise, it's always a problem. Problem is a problem. You recognize or don't recognize. That's what I say. Therefore, my dear friends, honorable friends, you are engineers. That's why I to extend my regards to you. You may be young or not young. You are having respected position in society. You have to respect that also, that you are having respected position in society. Society expects something from every engineer, and particularly civil engineer. They may speak or they may not speak, but they expect civil engineers to produce quality. But there's a picture that civil engineers are corrupt. It's very bad and unfortunate for every one of us. Quality is our responsibility. It's not political responsibility. It's not architect's responsibility. It's only engineer's responsibility. Quality system. They may say we take care. I'm not talking alone supervision. I'm talking of everything. Design should be respected and is honored only when you do quality work. And if you leave to people, you leave design in desert, then your design remains only on papers, on computer software, nowhere else. And you lose the beauty of your design, and that is awesome, that's awful. You can say you may not be able to get in what's required. That's main point here, and you can understand what I mean is. What my mean is, that as far as you know what you do, what you don't do, I think you should do that. It will not take much time now because I have to close down, so I'll be 8 or 5 some more, though I can move further, but let me do it tomorrow. This system is also heat, no, it's not, no problem. I'll take up this issue of contracts tomorrow after discussing some soil. I did not talk a lot on management also today. Management is very important part, because what we are doing is all management. Soil, management of soil, management of concrete, management of contracts, management of whatever talk in management designs. All is actually management, and that point must be respected by everybody. That is my intention and no other intention. With this, I thank you very much, dear friends, and I close this video. Thanks a lot indeed. Thank you.